over the last couple days, I've been going around to some different fields in the county and taking these plugs. These plugs are examples of how this crop is growing on the site. So we dug out with as little disturbance into this piece of soil as possible. So this is giving us a real-life simulation of how these crops are acting with the soil. So to give us a kind of a variety of treatments to this land, we have a potato field to kind of start things off with a little bit of variety. This is going to be heavily tilled for the potato crop. This is in an off season, so it's actually been planted with a cover crop, but it's not irrigated. It was also really interesting as we were actually taking these samples, also just observing some of these were much easier to dig into. Some of these were really compacted and difficult to dig out. Others were wanting to crumble out of the pan as we were taking the samples. So that kind of gives us another indication of the behavior of the soil and how it's performing for the plants. All of these soil types are a sandy loam, so we wanted to stay consistent so that we could compare apples to apples. These next two are from the same site. They're a pasture field. This lush, nice looking one is from the center of the field where it's been managed. It's been rotated and irrigated after the cows have come through. This is for the edge where the cows are compacting along the fence, and also where the irrigation wasn't quite reaching until the edge. So this was a lot more compacted and not irrigated. This sample here is a first year grass planting. And then this sample here is a 5th year grass planting. So we're going to be running the sprinkler system over the top of this and seeing what kind of runoff comes off in front.
Oh, actually, before you do that, just so you guys have a little thought process. So one thing that Dakota is really trying to demonstrate. Hi, I'm Nicole Lambertson, by the way. So I'm our nutrient management and research specialist in the office. Something to consider when you're looking not only at your soil health is whatever you're doing to your soil profile, so the top is going to affect everything that happens below that. We're looking at things not only like cover as Dakota described, so when you in your brain can think about what is bare soil versus a well-covered soil, how is that going to interact in a rain event, right? So in your brain kind of think about what you predict might happen there. And then think about also like rooting structure and depth. So some of you may rotate in potatoes, you may grow potatoes yourself, and you can think about that's an annual crop. There's a lot of soil work and disturbance there. There's a lot going on for the health of that potato crop, right? But it really disrupts and interrupts the soil structure and what's happening in that top layer. So consider that versus grass that's been in for 5 years. You've had a lot of rooting that's happened in that soil. Hopefully that's encouraged a lot of worms and microbes and various things happening in there. And you can also in your brain think about, okay, what are the differences between those two, not just runoff, but think about water infiltration. One of our biggest challenges in Whatcom County is water, right? Too much, too little. And the too much time, which is that fall, where we have still soil that's going to be a little bit more like this, a little bit drier. What is that first rain going to look like? What's going to happen to our soil from a runoff perspective in a water infiltration? And then you can think about later in the fall when your soil is saturated, right? When things are pretty wet, what is that also going to look like for that runoff versus that infiltration profile? So when you're thinking about that, what is a highly disturbed soil versus a soil that's had a lot of roots and structure and worms and bugs and all sorts of things making pores and various things through there? How in your brain do you think you might see a reaction when we start raining on this soil? For in your brain, think about what is a runoff going to look like? What is that infiltration? Because those things are opposite, right? If it's running off, it's not infiltrating. If it's infiltrating, it's not running off. We want infiltration. So just think about those things in your brain right before kind of this gets run. You can kind of see what's probably what we're setting up here to demonstrate, right? That runoff profile. So with that in mind, you may have one or more of these management profiles on your farm. You may have them nearby your farm. So this is a great demo of whatever you're doing or not doing. You can now see how that interacts. And so after you kind of see that demo, we can talk a little bit more about how to reach one or the other, why, really talk about the science about why something is happening here. But I want you to formulate first in your brain what you think might happen, and then we'll see what happens. Because sometimes this doesn't always go perfectly. So if it doesn't, we'll still talk about it, but fingers crossed, this will go great.
Thank you so much, Nicole. I also wanted to just shout out, this is Emmett Wild. He's a planner down in Skagit County. He works with a lot of dairies down there. And then Deirdre and Gabe, do you want to come forward just a little bit?
I'm Gabe. I'm a soil scientist, just started in January down at WSU Mount Vernon.
Same. I'm Deirdre Griffin-LaHue, and I also am a new soil scientist at WSU Mount Vernon as of January.
So we're all going to kind of tag team this as we evaluate what's going on once the simulation runs. So, lights, camera, action.
This is kind of simulating like a big rain, right? This isn't our little spritzy sprinkles that we get. This is like, okay, it's raining for real. So, and you guys are more than welcome to come forward and really look if you want to see what's happening on the soil profile with the raindrops. It's also really hot. This feels really nice. So feel free to come on a little bit closer if you want to see it. Stay back and down.
They do big demonstrations on like a couple hundred acres.
Yeah. Come try it on ours.
That's why I kept asking So as this kind of runs, it'll take a little while, but you might start seeing some immediate feedback on some of these soils. You might see them kind of take their time to do some different activities and profiles. And again, you can see like it's a pretty decent rainfall amount here that's coming, but this could absolutely happen October, November, right? We can get some of these really big rains on these kind of drier soil profiles. So thinking about that too, not only, these are all the same soil types, so we expect them to have the same infiltration potential, the same runoff potential. So now it's all about management. How have you managed it to keep that soil health being both structure and cover, also the bugs and various things, the pore space within that soil profile. Irrigated versus non-irrigated might also have a pretty good response. If you guys think about if you had a perfectly dry sponge and you put it under the sink, so you take a new sponge, right? It's real dry, and you put it under the sink, what does water do first? Runs off that sponge, right? It takes a little bit before water starts sucking in there, and then it really saturates that sponge until it's saturated, then it runs off again. So our really dry soils are the same. They're hydrophobic. In other words, they don't like water until they can start to collect a little bit of it, and then they're better at getting the water through the profile. So a non-irrigated soil with first rain of the season is going to be more prone, or it's going to be more available to have a big runoff event. So keeping up with your irrigation through the season really helps to actually reduce runoff potential by allowing water to come into that soil profile a little bit faster, a little bit easier. After that, it's about how you manage that to keep that water coming through the soil profile.
We're going to do this for another 2 minutes or so to give it a chance to hopefully break past that hydrophobic layer and give us a little bit of result.
Is there anything you guys are noticing so far here? You got a volume of water, you've got color of water. Start kind of thinking about why you might be seeing those different things. We've got written up what those are, so you can start postulating what's happening with that soil. very well, but if you wanted to step up and just look at like the ponding or pooling, that's another great thing. You guys might have spots in your field where you have ponding. What is that, right? Now you can really see that it's probably compaction. You may have a little different like pan of a different soil type that's more prone to compaction. You might have a low spot where you've had ducks and birds that are stamping that down and compacting it. And so you'll see things like ponding. You'll start to really see some of these things happen. This is a great example of that. And you can see what that ponding does, right?
All right, I'm gonna turn this off. Oh wait, I was gonna turn off up here first, right?
Yeah. Yeah, so we'll look at how much rain. So that was about, that's a 3, that's just under, excuse me, that's one and a quarter inches of rain, right? So in a very short period of time nonetheless, but totally plausible in our area, but more for a demonstration purpose. But just so you know how much rain that was.
Should we do a reveal of the infiltration?
Do you want to talk about overflow first?
Okay, yeah.
Yeah.
So you can tell, just looking at the color of the water, we're getting a lot more sediment coming off of these fields where there's not a good, healthy living crop to keep that soil in place. Where we have good green living cover, we're getting a lot less of that sediment running through. Interesting that this first year grass is a lot more runoff, but look how much cleaner that it is in comparison to those first two.
Why do you guys think a first year grass would have more runoff than a 5-year grass?
Root zone.
Yeah. Yeah, so I heard one, no roots, right? The roots are about this big. You've done a lot of till work to put that in first. Yep. There was another one over here in this.
The same.
Same. Yeah.
Less microbial development
Yep.
and porosity, probably.
Exactly. Yeah, so if you look down at that soil profile by tilling it and working it, you've disturbed that natural soil structure that's created all those nice pores and ability for water to infiltrate. So by breaking all that up, it takes a while, 5 years, let's say, for that to reestablish that rooting depth and everything else that comes along with that. However, you will see at least having cover, so that could actually be very representative of planting a cover crop after corn, let's say. You have a lot less sediment. You had runoff, yes, but you're losing less soil with it. Here you're losing soil with that sediment because you don't have cover. So this one you get both runoff and soil loss. And as you guys know, with soil loss, what's attached to soil and that sediment, we've got nutrients. If you've got manure on the surface, you may have that manure going out there. So really, we don't want to see color if we do have runoff, right? So think about that. When we've got soil exposed, you're getting color, which means something is leaving. All your hard work is actually leaving your field. This is hard work. That's all your nutrients and your work and everything you put into that soil structure is leaving. Versus there, we've got water off, but a lot less of your hard work leaving your soil top. These other ones, you can see there was no runoff down there and very little runoff. So a well-managed pasture that's irrigated, right? So we've been encouraging that soil profile to really have that moisture in it to do better with microbial production and infiltration and all those great things is very similar to an irrigated long-term grass field. So a well-managed pasture in a great grass field, you're getting the same benefits from those. A non-well-managed pasture is the same as having a bare field, just about, right? It's compacted, it's dry, we're not having cover, water's having a hard time getting through there. So even the edges of your field, which if the edge of your field is next to a stream, it's probably your most important part to really keep vital and healthy and good infiltration. You want to really think about managing all the way to the fence or to the edge, no matter the crop. So that's a really good demonstration of that.
We also have another sample here that we couldn't fit into this demonstration this morning, but this was taken in between corn rows. So this was an especially crumbly sample, no structure in this soil, and nothing has really grown in here besides weeds. At this point, there was a relay seeded into this field, but it just hasn't taken off in a way that is significant at this point. But if we were to plug this in here, I would bet you that it would be even a darker color and more dramatic than both of those samples there. So this cover is still doing something positive, but just not as good as these samples over here.
So if these all got the same amount of water on top, and you see what's there, where do you think the rest of the water went? Shall we
Retention.
see? Yeah, let's take these out.
It just pulls out. There you go.
All right, so now you guys can see what didn't run off infiltrated. That one pretty amazingly, right? That's what you want. You want water running through your soil profile to the roots, to the structure, down, right? We want it to get to somewhere where it's not going to be running off. We want it to get down to an aquifer where it can be stored for later use. We want it to get down to your very depths of your roots and everything that your soil needs. You want it to go down. These all being the same soil type, they all have the same capacity for that type of infiltration, but your management on the top has changed that, right?
And it's certainly not, we're not suggesting that you only keep all of your pastures and grass all of the time, all of your fields and grass all of the time. But it's something to think about if you are doing a lot of corn, how can you maybe increase your rotation so you have more years in grass between your years of corn, so that you're counteracting any of that disturbance that you're having during that corn year and trying to build up as much as you can in between those years.
Or even just getting a cover on top. So you guys can see, yeah, very little infiltration. Even the color of the infiltration down there is a little bit different. What do you think that color is representative as well? So the color, like it was losing your hard work off the field, this is really highlighting your hard work, right? Because if we had soil depth, you're not losing that, but you're really able to see that dark color means that you are building organic matter, you're building nutrient, you're building everything in that top profile that your crop needs to flourish and to do really, really well. So you're probably going to have better yields when you're able to build that up, and this is just kind of a color representation of that this is your bit of that management profile. However, we also want to always think about that's also indicative of something that we have a problem with sometimes in the fall time. That high infiltration means that if we have too much of something in that top profile, it's specifically nitrate, which likes to find water and travel with it. Other things like phosphorus don't like to do that, but nitrate likes to hang out with water. And so if we have too much of it left in that top profile that our crop isn't taking, it will go with water. And so that's why we can have challenges with high nitrates in our groundwater in certain areas. So that's a really good thought or visual for you too, to be thinking about really good nitrogen fertilizer management, whether that's you're putting on organic or inorganic fertilizers, manures through the year, to really be thoughtful about that, because in the fall when rain starts up, that's when that happens. Come spring, that's already left that profile, but that's why we really encourage in very well-drained soils that we start to taper off on nutrient application this time of year, because our crop is, especially in grass fields, your crop growth is kind of starting to decrease a little bit, but you have a ton of nutrient left over that your soil naturally will mineralize, that's built up over years, particularly in manured systems. Manure is one of the best things you possibly have on your farm. It increases your organic matter, it increases your soil health, it brings in so many great nutrients that really elevate that soil profile. It's really, really great for it. But if we mismanagement or we over apply, specifically in the fall, we can increase our losses of it through that soil profile. Same with the top, right? If we're not doing great management here, but in those grass systems, it's really good to think about that. You don't want to waste that really great product that you have. We want to try to manage it for the soil type, right? So our heavier soils, we can go a little bit longer into the fall, but our really well-drained soils, we want to back off right about this time of year, because you're just kind of building that up and the crop isn't taking it. It's just going to rain right through that profile. Okay. Oh, it's heavy. Yeah, these are really surprisingly heavy.
So the last thing to look at in this demonstration is what this looks like on the opposite side of this pan. That might tell us a few things. So we're actually going to flip these over.
Well, before we do that, what do you think we're going to see on the back side of these pans? So what we're looking for here is how water moves through your profile. And when we flip these over, you'll be able to see hopefully wet and dry profiles on the bottom of these. So before we flip them, in your brain, what do you think these are going to look like based on how our runoff versus our kind of infiltration water profile width? So in your brain, just kind of think what you think these might look like, and then we can flip them.
The water holding capacity of each of these soils can be observed by flipping the samples to see where water has been absorbed. Soils with good water holding capacities are able to catch and absorb water as it flows through the soil profile. That water is then available to be taken up by plant roots. Soil with poor water holding capacity remains dry as water passes through because there is limited pore space and organic matter to absorb the water. Soils can also become hydrophobic or develop a hard pan, which limits water infiltration beyond a certain depth. Water holding capacity is determined primarily by soil texture and organic matter. Soil textures with fine particle sizes, like clay or silt soils, have more surface area to slow down and absorb water as it flows through the soil profile. Soil textures with a coarse particle size, like sand, have less surface area. Water flows through more quickly with less absorption. While soil texture is unlikely to be changed by management, increasing organic matter in the soil is a great way to improve water holding capacity. Soil organic matter can be increased through practices like cover cropping, reducing tillage, increasing crop rotation and crop diversity, and incorporating crop residues, compost, and animal manure.
So once again, we can see where that infiltration was, and even in some where we kind of thought there was a little bit more, like in that first tier grass planting, there's still all this dry area around here that didn't get any water to those roots in that area.
Yeah, so if you guys really kind of equate these back, you can see how the wetting was just uniform and beautiful, really went through. That's a sign of a great, healthy soil. Not so much here. This is wet around the edges where you can see the roots are, and or where the edge of the pan is. There's just a little bit of that happening. This one's like completely dry. There's very little water getting through there, and even a mixed amount in that one there, in that tilled one. But yeah, if you guys want to come closer, you can kind of look at, it's kind of neat to see where it's coming through, where there are the soil, where there's roots and how it got through or it didn't, because the soil's preventing that. Maybe it would just take more time. Where you've got soil cracking, where you've got really nice profile and the soil sticking together. Again, same soil type, right? So these all have the same potential to look the same. But again, they're a little bit different with the crop and management on there.
We also have, this is something that we've just borrowed for this day, but we have a miniature version of this where we can take little small plugs. And we have these in the office. We'd be happy to bring these out. Scarlett is a specialist in this area. We can do a miniature version for you if you would like to compare a couple different fields or a couple different treatments as you're making your management decisions.
If you want to do like a big management change, these are great. Like come out, they're easy. They kind of, we can demo it at lunch and show you guys. They kind of stomp in. You can do a little mini demo of this, make a change over a year or so, do it again. See how you have changed your soil health and profile, your infiltration, your runoff. You can see everything. Or you just want, you're curious like, how is my management? You know, what am I doing out there? Happy to come out and just do these. Doesn't take very long. A little tailgate demonstration.
So we're going to move on in just a moment to some of the research that Nicole has been doing. First, Emmett's going to just talk a little bit about things that he's observed in Skagit County and things that producers down there have been working on for soil health.
Yeah, so we do a lot of that. So I wanted to start talking a little bit about infiltration, but first, could I have a couple volunteers? Sure. All right. You prefer corn or grass?
Corn always tastes better to me.
Oh, we'll do grass. So you have a ring over here in the corn, you have a ring right here in the grass.
Yep.
And I'm just going to ask you both to start. And try not to spill it over, but try and keep it as full as you can. And we're going to have a race just to see who infiltrates that entire gallon of water first.
Keep it at the rim.
Try and keep it near the rim. And this isn't going to be a fast process, so.
Yeah. Okay.
Thank you. All right,
we
ready?
cheer?
Go. You can cheer, but
can take bets.
this isn't going to happen in a minute or two, so.
One's into grass and one's into soil. Is that what's going on?
This is grass. This is into the cornfield.
And so maybe tell about the history of these two.
Yeah. So these two fields, basically, this is all according to Troy, right? So this field has been in grass for, I can't remember exactly. He said it was 8 years, 7
I
years.
think so. 7 years.
So this has been in grass for 7, 8 years. This one was in grass, same as this one up until recently, and this is the first year of corn. So this is just 1 year of corn. So we'll just kind of see what happens there. With that difference. And I'm going to kind of keep talking and showing some other things while this proceeds, because infiltration isn't always a quick process when you're trying to infiltrate a gallon of water through that small little ring.
From our earlier demonstration, I think I might win this.
Yeah. The
Well,
corn
so-
ring's just sitting on undisturbed
Yeah,
soil.
it's looking that way.
It's sitting right between the
Yeah,
rows of
you
corn.
guys didn't disturb it or anything.
No,
Okay,
this is
got
just
it.
kind of, yeah,
Got
just what's in between the rows. We did just cut down some corn to make it a little, well, I didn't do it, but yeah, thank you for doing that, to make it a little easier to see. And so the reason I thought it'd be interesting to show this is just because when we're looking at the demonstration with the erosion boxes, what you're seeing is very much a surface effect. And I think that's really important because what's happening on the surface of your soil obviously plays a huge role in how much is infiltrating, how much is running off. But there's a lot more going on that we know, right? And so just because the surface maybe infiltrates really well, that doesn't mean necessarily it just keeps infiltrating real well. And so if you're just doing, a rainfall event for a short amount of time, great. If it's raining for several days or something like that, okay, well, we need to think about what's happening in the subsurface as well. So thank you very much to both the volunteers. I'd ask you to keep going. I'm just going to kind of show a couple other things while we're going. So this is something else I wanted to show. I'm going to open this up here. So this is, what I did here was I infiltrated a dye. So this is basically a dye tracer that moves with water. Just give me a second to dig here. Sorry, Troy.
We'll fill it in.
Didn't know what you signed up for, huh?
How deep down do these rings go?
So those rings, they're about 4 inches total. So you see about 2 sticking out. So they're going just another 2 inches or so, and that's just to prevent it from spreading out. But hopefully once it gets down there a bit, it's not spreading out too much. One thing that is interesting when I dug out this before is all of a sudden you get to a pretty abrupt textural transition. I don't know if you all see that in your field. Anybody farm close by? No?
Huge variation
Yeah.
in soils.
Hope we have a winner.
Do we? Can you get the rest in yours without overflowing it?
No, it's overflowing just about right now.
Alright, so,
I have probably a third of a gallon left.
Grass is a
well, so thank you very much. You can definitely keep trying to infiltrate if you want, but
Stay in the
but I mean, I
shade
think
there.
that's a pretty big difference. When I did this earlier, came up last week and did something similar, that one took me about 12 minutes from when I started pouring to when it was completely infiltrated. That one took me over twice as long. Which still, that's not a bad infiltration rate for getting a gallon in that. But this is also, pretty sandy loam soil, and so you're gonna have a relatively high infiltration rate, and so just 1 year of corn is making the difference that it's over doubling the infiltration rate. Thank you both very much. I appreciate that.
If anyone needs any drinking water, there's a third of a gallon.
So
Pocket of shade.
Yeah.
just open this up a bit, but if you all want to kind of come around and take a look. I can also pass out some handouts of something similar we did. But so what this is this is a dye. And this dye is it's basically a food dye, so it's non-toxic. And this is just going to be moving with the water. So
how much water did you pour there? Was that one of these rings? Did you pour a gallon out of one of the rings, or how?
yeah, so I put in a ring basically, and then I'm pouring just under half a gallon in each of those. But I think that
Come on this side.
is that a mold?
In that ring that you used, how much in inches would that half a gallon be?
How much in inches?
Yeah, like it
That's a good question.
To a
Is it rain?
rainfall
Is it-
equivalent.
Yeah.
Like to get it to run that deep into your soil.
In the water.
For the gallon?
Yeah,
Oh.
in that size ring.
Yeah, that's a good question. I honestly don't know the exact answer to that, but it's right around 4 inches.
I'm
I
surprised
would
it went down
estimate
that
around.
far, actually.
Well, so this is only half. This is only half as much as that. And the thing I want to point out is just I'm standing in light now. But if you see, kind of just there's whole sections where you're missing. You know, where you just get this really spotty. So this dye is just moving with the water. So that's exactly where the water is going. And so that's preferential flow, right? These are flow pathways. And we talked earlier about the importance of having living roots in the soil. And I think living roots are really important. What also happens with the grasses when they've been established, you get dying roots too. And having that kind of balance of living and dying roots, constant root turnover, that actually really helps get water infiltrated faster, because it's not just kind of right around the root where the water's going, but it's these old root channels. Root turns over, leaves a pore, and it also just helps aggregate the soil so you can get deeper infiltration. Now, as Nicole talked about, there's kind of a balance there, right? Because that's great for getting good infiltration and for getting a lot of water into the soil profile. Depending on how much preferential flow you have, you know, what's that carrying down with it? So if you are having these pathways where it can kind of go down and maybe carry some nutrients with it, that could potentially be a challenge. But then you just got to think about kind of, well, how deep are those actually going to be carried, and you know, when does this stop, and are you actually, say, losing nitrates to groundwater, or is it just that they're getting deeper in the soil profile and that they're still going to be available for uptake? You know, because there's roots that are going down pretty far in this case. Any questions on that so far? Let's dig up this one real quick.
Earthworms help a lot too, right? Or creatures in the ground.
Yep, absolutely. Yep.
Which I didn't notice.
I saw one when I was just digging there.
Yeah, they're in here. But yeah, like the worms will create those kind of pore spaces, or you'll get critters in here that will do the same. And well, those are great. Sometimes they're like, as Gabe said, preferential pathways, flow pathways. So they're like a water slide of water that's not having a chance to infiltrate, or even things like manure that we apply to the surface. If we have some of those big holes that come from the surface down, that can be a challenge sometimes. So having kind of this really nice, you know, having different types of distribution in the soil helps that a lot. I don't know if there's anything else you want to add to it. And the dying roots, or even like tilling in like cover crop or any kind of cover, that introduction of organic matter really helps support water infiltration as well. So, you know, just scraping off, let's say, the top of a cover crop and removing it wholly isn't going to help, but if we till that in, it actually does help us somewhat to bring water at least through that top profile.
Yeah, and maybe I can start a little bit of what I was going to talk about, which is very much in that vein. What we understand now about organic matter and getting that organic matter into the soil is that it really needs to interact with the soil minerals, and that organisms like earthworms and microbes really play a big role in getting that integration of organic matter attached to minerals, and that's how we really get it to stick around a long time. And so it's really, we've been talking a lot about all these functions of soil today. So briefly, I just want to start by having you summarize what are the things that we look for in our soil. What are the things you want your soil to do for you? Can we list off a few that we've talked about today? Retain water, yeah.
Grow crops.
Grow crops. So nutrients, a good stable surface for crops to grow. And water availability for the crop. What else? What do you want your soil not to do?
Runoff.
Runoff. You don't want runoff. You don't want ponding, right? Compaction. So you want it to be pretty workable. So these are all things we've been talking about today, and a lot of these are driven by microorganisms. So they are the ones that are creating the soil structure so that water can flow through, water can be held in the soil. They're the ones that are releasing nutrients to crops.
But the thing I wanted to point out here is just that one, you didn't see that you don't see the dye going down quite as far, and you definitely see a point where it kind of there's a lot of dye, and then all of a sudden it kind of stops and gets to be much smaller. And you can see that already we're kind of creating a little bit of a compacted layer where that's building up an impediment to water flow. And so that dye is kind of sitting there, starting to spread out a little bit more, and that it's not moving down in the soil profile as well.
Yeah.
Would that be the bottom of the flower?
Mm-hmm. Yeah, I mean, I don't know exactly what tillage was done here, but yeah, I would say that's probably a compacted layer from some of the tillage done right before the corn was planted.
With that in mind, so someone showed us a cool trick recently, and actually I'm going to just borrow one of these. So if you take one of these, if you have a flag, anything like this, a great compaction test to do that, is you can kind of come over into wherever your soil profile is and see how easy it goes in, and then at some point it's going to stop. And you can pull that out and then go over and look at like how it matches up to your tillage equipment. And most likely it's right on. So you can see what is that depth down to which you have that compaction layer, and this dye is probably a great representation of that. Or do it in grass right here.
And I also wanted to mention it in the terms of water holding capacity, because I know Nicole was talking about your irrigation and how, you know, getting some more organic matter in the soil like you do with the manure and getting better soil structure can really help with water holding capacity and the ability to kind of go a little bit longer before irrigations. So these are a couple examples I just wanted to pass around. This is from, this is very different soil than here, right? Not nearly as sandy, but
Moved up our way.
this is actually down in Mount Vernon. This is a silt loam soil. So this is a experiment where they had 2 years of biosolids applications, right? So not manure, but a very similar kind of idea. And then they did, I'll give you that it was a large amount. You know, they were putting on a large amount of biosolids over 2 years, but the difference it made in these soils is pretty incredible. And I'll just pass some of these around where you can see kind of the difference in soil structure.
So that was the same field in essence?
Okay. Yeah, and so you can see the difference in kind of the weight of them, how much porosity there is in one. And again, this is a lot of biosolids over 2 years, but think of, okay,
so
well,
how much?
It was about 60 wet tons.
Over the 2 year period, with what kind of tillage or incorporation?
You know, I don't know exactly how it was tilled in or incorporation, so I can get back to you on that. But this is a bit before my time here.
Oh, right.
But I guess the point I want to make is just that, okay, well, you don't have to be putting on an insane amount of, you know, an organic amendment like that just in 1 year, because you have access to manure. And so think of what that's doing over time, that very same kind of thing. So that's the last point I wanted to make, just about water holding capacity and how important it is to get that good soil structure and to open up some porosity.
Soil infiltration, water holding capacity, nutrient release, workability, not a lot of compaction. So these are all driven by microorganisms, and a lot of the tenets, the management strategies that we want to employ. So not a lot of disturbance, living roots, cover, biodiversity. Those are also all related to ways that we can increase microbial activity. And so microbes, as I mentioned, they're the ones that are breaking down a lot of the organic nutrients that are in your manure, breaking down the carbon, releasing nutrients to the crops. They're the ones that are breaking down crop residues and turning it into sticky organic matter that's going to hold soil particles together. So here's just a few images I'm going to pass around. These are all the same. So this is showing the difference between fields that have had a lot of organic matter and those that have not, and just how well the soil is held together. So the two black and white images are actual really, really zoomed in images of basically like silly string that microbes have put out to that are actually acting like kind of like bungee cords to hold soil particles together. And there's also fungal hyphae that are acting like nets that are basically holding soil particles together. So the reason that's important is because it creates that good structure. It creates those pores, those big pores that are going to allow water to move through, and it creates the small pores that are going to hold water so that your crop can have some moisture in the spring. So and through the summer. So having the diversity of pore space is really important, and it's the microbes that are creating those particles, those substances that are going to act like silly string and hold particles together. And so how do we measure that? So we've been doing a lot of in-field measurements that are a good way to test for soil health, doing infiltration, looking at compaction, looking at runoff. But there's, how do we look at the microbes? How do we know how active they are and what they're doing? So there's a few ways to do that. And so microbes, when they're breaking down the things that we're feeding them, when they're breaking down manure and crop residues or cover crop residues, they're releasing CO2 just like we do. So we can actually measure the amount of carbon dioxide that they're respiring. And so that's a good way to look at microbial activity. And so you think, well, maybe that's kind of counterintuitive. I don't want all the carbon I'm putting into the soil to be going away through microbial respiration. But in order for them to make the substances, the sticky glues that they make, they have to do some of that. And so what you can do is a Solvita test, which actually measures the respiration of the soil. And these are completely humidified now because they've been sitting out in the sun. But I have here, this is from this cornfield, and this is from the grass field here. And so I compared these two to the same fallow field that Gabe had talked about in his infiltration measurements in the pictures you saw. So it's a field that it had a corn crop, but it's had a lot of fallow and just a lot of tillage and not a lot of organic matter going in. And so if we look at the health of these, I'm going to have to pull these out. If you buy this test, it'll give you a little color scale. Here we go. So it'll give you a little scale from blue to green, and these paddles will show you how much respiration has happened over 24 hours based on the color. And so they start out blue, and as they get lighter and lighter green, that shows you that you've had more and more respiration. And so this is the corn, and this is the grass. So they're pretty similar. They've both had quite a bit of respiration in 24 hours. I would say they're both around level 3.5 to 4. And so then if you look at your manual that comes with it, that's around the ideal activity of microbes in the soil. So it's an ideal amount of respiration coming on. And so what that means is that there's a good amount of microbial activity in the soil. They're going to be releasing nutrients because as they respire, they're releasing nutrients to the crop. So there's a good amount of microbial activity. And they're also releasing nutrients and creating those sticky substances. So if we compare this to our fallow field that has not had a lot of food for the microbes, you see that color? It's much darker, right? So this is around, I'd say, a 2. So it has much less microbial activity in it because it's had less food for the microbes. And so again, it's really important to feed the microbes in the soil so that they can create the benefits, the functions that we look for, like here, where we look for good structure, good drainage, good nutrient release. Any questions about that and respiration? Yes?
How do you get a 6?
How do you get a 6?
Is it possible to have too much microbial activity?
Yeah, so good question. So I mentioned that the respiration, it's showing that the organic matter is being released, it's being digested by microbes and being released. So you don't want too much of that. You want a good balance because you want some to stick around in your soil and some to be released. And so if you look at this, I know this is really hard to see, but there's kind of an S curve here where there's really low microbial activity over here where you have your 1s and 2s. And then this is kind of the ideal level activity, and then over here it says very high activity, and that means you're going to be losing a lot more of the organic matter that you're putting in. So you might get really, really high, like a level 6, right after you apply manure perhaps, because there's just tons of food and tons of nutrients for microbes to eat. But then once things settle down, once you've applied it and your crop is growing, then you want to be more in this middle range where there's a good balance of microbial activity, but not all of your organic matter being blown off. Does that make sense? And again, this is tied to nutrients. So, there's a slow release level of nutrients from your manure, and so you don't want it all to be released at once. You want it to be kind of slowly released over the growing season so that your crop can continue to get nutrients off of it. And so another way to get at that is to actually test how well they can break down something. So this was from, again, the same fallow field. This is down in Mount Vernon. So this field had very few organic matter inputs, so not a lot of microbial activity. And this is from the same 5-year alfalfa field that Gabe tested with the infiltration. So 5 years of organic matter inputs. And I buried these t-shirts to test how well the microbes would be able to decompose them. So you can think this is kind of similar to if you had corn residue. How well are the microbes going to be able to decompose it? So this is from the fallow field. It's a little baby t-shirt, it didn't shrink. But there's a few holes in it. You can see. You can come up and look later. There's some holes in it. They were definitely degrading at some. But if you compare it to the alfalfa field, let me see here. A third of the t-shirt is completely gone. So what does that mean?
Bugs were hungry.
Bugs were hungry. Bugs were there. Bugs were ready to eat because they'd had lots of food. They were ready to go. And bugs were hungry. So you're going to have a lot faster decomposition of your residues being turned into good organic matter that's going to help with all of these functions we've been talking about today. So continual feeding of the microbes, there's some other parts of the t-shirt here. Continual feeding of the microbes is really going to help you have good microbial activity and help create all these functions that we're looking for. Another way to test that we do in the lab, which you might, if you ever get a soil health test done, has anybody had a soil health, sent soils to a soil health testing lab? So a few people. So they're really different tests than are done on a traditional nutrient test. So you might need to figure out a little bit what they mean. And so one of the tests that you might see is called active carbon. So what does that mean? How is it different than the organic matter that you get on your soil nutrient test? So the active carbon is measuring how much readily available carbon is there already in your soil. So how much readily available food is there for microbes to take advantage of. And so we can do a test. We add this really, really dark purple dye and see how much of it is decomposed. And so it's kind of acting like food for microbes. It's kind of acting like microbes. It's eating up the carbon that's in the soil, and however much is left, however much is gone is how much it was able to eat up. And so we add this really, really dark purple dye, and then we see how much color is left. And it's a little hard to see with the naked eye. In the lab, we would actually be able to tell exactly how different these are. This is a test I did yesterday. This is the grass field here. This is the corn field here. And I don't have the dye, but it's like extremely, extremely dark purple. And you can see, maybe, you can come up and look, the grass field's a little bit more purple than this cornfield. And that might be because of the tillage that was just done, so it breaks up some of those aggregates and releases organic matter to microbes. It also could be because of the solid manure application that went on this field. So there's a little bit more active carbon in this cornfield than there is in the grass field, but I'll tell you, they were both very, very high compared to a lot of the active carbon measurements I've seen in other fields. So they were both close to 900 to 1,000, which is a very high number compared to some of the other fields that get very low organic matter inputs. So that's a really good sign. It means there's good soil health, there's a lot of food for microbes to eat. Adding that manure, adding the the grass, you know, this had 7 years of grass before it went into corn. It's really doing a lot for soil health. It's really helping with all of these functions that we're talking about and providing good food for microbes. So we're comparing these two different soils, which aren't super different, but they're both really, you know, doing well in their soil health. And we saw with the infiltration rate, even though there's some differences, they were both really fast, you know, doing well. Any questions about that?
Soil type make a difference on that?
Yes, soil type does make a difference. These were the same soil type. These were the same soil type. They were fields right next to each other. But soil type does make a huge difference. The level of clay that you have in your soil can really impact the amount of organic matter it can hold. So one thing that we're hoping to do statewide that I'm working on is figuring out for all of these different soil types we have, you know, even in Western Washington, even statewide, there's so many different soil types. How do we know what type of values we want in our all different soil types? A lot of the work on soil health and coming up with these scoring report cards has been done in the Midwest, you know, in the Northeast. So they have very, very different soils and systems than we have here. So there's a group of us that are working on developing, you know, what are target values for all the different systems we have in Washington, for all of the different soil types we have in Washington, so that we can know, you can send in your soil sample, say this is my soil type, this is my, you know, system, and this is the, you know, score that I'll get back, and it's not comparing it to fields in Iowa that, you know, used to be prairies. So we're trying to develop better scoring systems for soils in this area. But yes, soil type makes a huge difference. So when we do these comparisons, we try to do similar soil types. Yes?
Glyphosate, does it have any impact on bacterial life in the soil? Are there any tests done on it?
There has been some research done. I'm not super familiar with it. I know that, I mean, it's a carbon source like a lot of other carbon sources, so a lot of microbes will break it down, but it may affect some other microorganisms. So there has been some research done, but I'm not really familiar with the results of that. It's not quite my area. Any other questions?
So from a tillage standpoint,
Yeah.
there's not a lot we can do with a grass field, but with a corn field, particularly on a heavier soil where it gets more compacted, chop and everything like that. Should we be going through in the fall and dripping that to get more air into it, or should we leave it alone?
I would say, so the moisture content of the soil when you till is really, really crucial. If it's too wet, it's really gonna just like create mud. And that's gonna it's gonna take a long time for that to recover. The problem is that soil is slow to change, so there's a little bit of a turnover time that it takes once you stop doing a lot of disturbance. It can take a little while for those root channels to form, for microbes to come back and get into gear, for earthworms to come and do a lot of the mixing that we get. And I'm not advocating for no-till. I think, you know, these systems are you know, you need to do some tillage. And it's like we were saying, it's good to kind of mix organic matter. You know, if you have that cover crop, get it back into the soil. But you need to be really careful about when you do that, how wet your soil is when you do that. And I know that here it's challenging because, you know, the rains come early, it rains late into the spring. Soil can be really wet for a while, but that is a really crucial aspect.
Well, that's why I brought it up. Like in the fall, if the soil is drier, you get more shatter. Versus in the spring when it's wet, you get more compact. You don't get the same effect.
So there's like an intermediate. I know it's not always possible to hit that right moisture content, but I mean, deep ripping is going to. You're going to get shattering of aggregates. You're going to start to get compaction. You're going to lose the structure that you've been building with the organic matter. So it's kind of a hard balance to hit. But I would say, you know, reduce the amount of disturbance as much as you can. You know, maybe you can do lighter equipment. Maybe you don't have to go quite as deep. Maybe you can just do a pass, because it is kind of breaking things up. And over time, you're going to lose some of those functions that you look for. Does that make sense?
dry soil compared to one that's, and what's the
Yeah.
respiration between the two?
Yeah. So the question was whether I'd looked at a really dry soil versus a wetter soil. So this was some work I did actually down in California. I haven't done it up here yet because we're just new. But I did compare soils that had more even distribution of irrigation. So more of the soil was getting wet versus very precise irrigation where a lot of the soil wasn't getting any moisture. And I did see that there were changes in microbial activity. The biomass of the microbes went down in the dry soil, so they couldn't survive as well. And there was more buildup of nitrate and things because they couldn't take it up. So microbes are not only releasing nutrients, but they're also taking up some nutrients, so they can kind of be a slow release sink of nutrients also. So there's more of a buildup of nitrate that could then be more easily lost when we did get a rain event. And we did see a change in what types of microbes were there. So it can really affect, the microbial populations. And there's a lot of work being done on, okay, which microbes are there, which microbes are where, how am I affecting the types of microbes? And there's still a lot we need to understand about, what type of microbial community are we looking for? We can get some information on looking at the ratio of fungal microbes to bacterial microbes. But there's a lot we still need to understand about, okay, well, what type of bacteria are we looking for? What are they doing, and how can we promote those types of microbes? So it's like the holy grail of soil microbial research right now. So hopefully in the next few years, we'll have more information